Let's explore the fundamentals of the relational model, which is a crucial foundation for understanding databases. We'll cover the essential concepts of relations, tuples, attributes, and domains to build a strong understanding. Get ready to dive in. A relation is a fundamental building block in the relational model. Simply put, a relation is a two-dimensional table that organizes data into rows and columns. This table is the core structure for representing a set of related data. Consider this table as an example. It contains student information with columns like student ID, first name, last name, and major. Each row represents a unique student, and the entire table represents a relation. Now let's discuss tuples. A tuple is simply a single row in a relation. It represents one specific instance or record of an entity. In our student table example, each row represents a tuple containing information for one particular student. Each tuple contains exactly one value for each attribute or column. The order of tuples in a relation does not matter. Here we are highlighting a tuple that shows details for student ID 101 John Smith, who is majoring in computer science. Let's explore attributes. An attribute is a named column in a relation. It represents a specific property or characteristic of the entity we are storing data about. Each attribute has a name such as student ID, first name, or major, and a specific data type like text or numbers. Attributes define the structure of a relation. Each attribute takes values from a specific domain. So, you can consider the major attribute in our student relation. It represents the academic major of a student. It draws values from a domain of valid majors such as computer science, mathematics, or physics. Let's talk about domains. A domain is a set of allowable values for an attribute. It defines the data type and any constraints for that attribute. You can consider it as a pool of values from which the actual values in a column must be chosen. Domains are helpful in enforcing data integrity. Looking at our example, the student ID domain might be defined as integer values between 100 and 999. The major domain is defined as a set of valid academic majors like computer science, mathematics, physics, and chemistry. A relation schema defines the structure of a relation. It specifies the relation name, the attributes or columns, and their corresponding domains or data types. Think of it as a blueprint for the relation. It remains relatively stable over time and also includes constraints like primary keys, which we'll discuss later. Here is an example. The create table statement defines the student relation schema. It specifies attributes like student ID, which is an integer and the primary key. It also specifies first name and last name as text values that cannot be empty, along with other attributes like major, GPA, and enrollment date. Now let's delve into relation instances. A relation instance is the actual data stored in a relation at a specific point in time. It contains a set of tuples that conform to the relation schema. The relation instance changes over time as data is inserted, updated, or deleted. It represents the current state of the relation. The notation student ID, first name, last name, major, GPA, denotes the schema of the student relation. The table here represents a relation instance, showing the actual data values stored in the student relation at a specific point in time. The instance contains the actual data values at a specific time. Let's discuss some important properties of relations. Relations are flat tables with no hierarchical structure or nested relations. Each cell contains exactly one atomic, that is, indivisible value. A relation cannot contain duplicate tuples. Each tuple must be unique, ensuring entity integrity within the relation. The order of tuples or rows in a relation is not important. Relations are sets of tuples, not sequences or arrays. The order of attributes or columns in a relation schema is also not important. Attributes are identified by name, not position. Each value in a tuple must be atomic or indivisible. Multi-valued or composite attributes must be broken down into atomic components. Within a relation, each attribute name must be unique. However, different relations can have attributes with the same name. Keys play a crucial role in the relational model. Let's explore some important types of keys. First, we have the primary key. A primary key is a minimal set of attributes that uniquely identifies each tuple in a relation. No part of a primary key can be null. Then there's the candidate key. Any attribute or set of attributes that can serve as a primary key is called a candidate key. A relation may have multiple candidate keys. Finally, a foreign key is an attribute or set of attributes in one relation that refers to the primary key of another relation. Foreign keys establish relationships between tables. In this example, the student ID is the primary key. Email is the candidate key and department ID is the foreign key. Let's quickly recap the key concepts. A relation is a two-dimensional table that organizes data into rows and columns, representing a set of related data. A tuple is a single row in a relation that represents one instance or record of an entity. An attribute is a named column in a relation that represents a property or characteristic of the entity. A domain is a set of allowable values for an attribute, defining its data type and constraints. A schema is the blueprint of a relation that defines its structure, including relation name, attributes, and their domains. Finally, keys are special attributes or sets of attributes that uniquely identify tuples and establish relationships between relations. The relational model provides a simple yet powerful framework for organizing and manipulating data. Understanding these fundamental concepts is essential for effective database design and implementation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.